First of all, good morning to all global climate leaders, and thank you very much for this opportunity. So I'm Dr. Ishan Purohit, and I am a program specialist with the International Solar Alliance. And next few minutes, I will be talking about streamlining solar success through harmonization of quality assurance measures for scalable impact. So, implementation of solar is not very new. We know that global market is very cooperative for this one. We have very large capacity numbers. Just considering the case of India only, last 3 months, more than 25 gigawatt capacity has been added. In last 2 years, more than 1,000 gigawatt capacity global has been added. So big numbers are there. But if we see, uh, the penetration is not, I will say, uniform across the globe. And there are several challenges which still countries are facing. So few are them, especially when we are talking about bankability. Quality assurance measures is one of the key aspect. So ISA is trying to address this challenge, especially for global South countries. So the way we see this entire segment is solar energy technologies. The uniqueness of technologies is basically the range of solutions which solar energy gives. None of another technology gives. It can give you from milliwatt to gigawatt type of capacity, and very small requirement of energy to very large. And nowadays people are talking about firm and dispatchable, so very comparable with the thermal or conventional source of energy. And its components or associated technologies are, for example, we are talking about the battery storage. Again, it is giving you solutions from some milliwatt hours to some gigawatt hours. So this is basically the big range of technology. Or application wise, if we see that the conversion efficiencies are around 10 to 25%, and if we do jugglery, so up to 40 to 50% with hybrid we can achieve. Similarly with solar thermal technologies, if we believe on fundamental heat transfer, so we can achieve temperature of sun through solar energy collectors. So there are a lot of technologies which are very much suitable for medium process to, in fact, the high temperature applications up to power generation and industrial process heat. And in this segment, the efficiency is pretty high because it is the thermal conversation of solar radiation. So this one side, it is very attractive that we are actually able to, address almost every type of applications which human beings are looking. But other side, if we are looking from financial feasibility of the technology, so all technologies are actually not financial feasible, and different type of challenges are there. So that's why quality control measures are very essential, because investors or the customer need insurance on the return on equity or return on investment. So because solar energy is intermittent in the nature, there is a fundamental equation. If we are talking in terms of energy, so it is radiation into area into conversion efficiency, and very simple physics is there. Efficiency could be guaranteed by manufacturer. In fact, area could be guaranteed by manufacturer and what type of application we are doing, but we cannot guarantee incident solar radiation. And that's why the performance prediction, especially in terms of safety, reliability, and promised performance. For example, I am doing a project where I am taking some assumptions on capex, opex, technical output, CUF of the plant, and operation and maintenance aspects. So if it is not repeatable, my project will be certainly in the risk. So that's why heavily we need to rely on the what type of quality control measures. I am not categorically saying is the quality standards directly, because some technologies are very advanced and some are emerging. And in case of solar energy, we are having a technology and we are having an application. Same solar PV module could be used for a power plant, and same could be used for a the supplying power through battery storage to some telecom tower or some water pumping application. So all these type of systems follow different type of aspects, and the quality control measures varies. So the way ISA is looking on this one is, we are approaching and we are following a two-dimensional approach and considering across the globe whether is it possible to consider a single performance standard across the globe, considering all type of climatic conditions, and how to implement? So One side, we are working on developing a global quality manual, which will be comprising all sorts of technologies which are existing and commercially available or in the path of commercialization. And it will be through either IEC, ISO, ASHRAE, country-specific standards like BIS, UL, those type of standards we will be compiling. We will be coming out with a global quality manual, and then these manual need to be adopted by the countries. So with ISA member countries, we will be working on the implementation or institutional arrangements for implementing and following up these standards. Once it is done, then any country, whether it is making, within the country, the manufacturing is done or they are importing, they can follow a process of testing and certification, and that could be adopted by member countries. Just giving a case of India specifically. So in country, if you see the way it is structured, it is not basically technical aspects, but we need to think from implementation and institutional arrangement for this one. So there are research laboratories and research institutions which do research, and those researchers are converges in form of test standards and then adopted sometime in-house by IEC, ISO, BIS, UL, and they come out with basically the standards which need to be adopted by the country. Then there are agencies, for example, again in India, if we are looking for implementing a large scale solar power plant or any solar technology, there need to be there is a mandatory condition to have certification from Bureau of Indian Standard. And Bureau of Indian Standard is institution, it is not a lab. They actually approach national, this is NABL, this is the quality assurance institution, which actually take care of identification of suitable laboratories or test centers and authorized or make sure that they are able to do these type of testings. For example, IEC 61215 is for crystalline modules of silicon, and it is tested by NABL and BIS accredited laboratory. For example, there is National Institute of Solar Energy, there is TUV, there are more than 10 such type of laboratories existing in India. Once they are certifying it, then only project developer or whosoever is putting project at any location, they will get clearance for implementation of the project. So all technology, as I mentioned, are not on same platform. For some technologies, there are standards available. For some technologies which are emerging, because this is emerging area, every week you can see new model is coming, new battery is coming to the market. So specification are changing. So there are codes and there are minimum functional specification as well. So our intervention on quality assurance manual will be taking care of all, basically compiling the global research through standards, then developing codes and adoption of the best practices and how to replicate in ISA member countries. So this approach we are actually following. So ISA will develop a global quality assurance manual for solar technologies and systems. So whatever type of system, whether thermal, whether PV type of system, off-grid, on-grid, any type of solutions which is available and available in the market, somebody can provide this technology to users. Then we will be working with the countries to develop their institutional mechanism. For example, any member country where we are working with, they will nominate an institution. Our manual will be given to him, and then we are having our solar technology application centers in various countries. In 12 countries, we are operational, and we are targeting around 50 such type of centers will be there by year of 2030. So all these test centers, these are right now, these are our training centers, but we are planning to basically enhance them to conduct testing and certification. So our star centers will be having this quality manual and make sure that the country who is looking for implementation and testing services, they will be going to star C. Some tests they can do, and otherwise they can approach ISA's new intervention called Global Capability Center, which is backed by IEC approved laboratories or NABL approved laboratories. For example, we are closely working with National Institute of Solar Energy. Just an example, if a country like Senegal, they approach our Star C that, okay, they need a testing certification or testing services or quality assurance for a product. Our Star C will approach our GCC, and GCC will make sure that, okay, NICE or similar type of institution is giving that services and making sure that the product is qualified or non-qualified as per the IEC or as per the applicable test standard in the country. So for this, we will be having a detailed plan for implementation. Through Star C, we will be doing the capacity building or the strengthening of the laboratories, and it will be developed through our GCC, regional and international collaboration. So I will stop here, and this is basically on prima facie ISA's plan for testing and standardization of solar energy technology and systems, and which will be implemented through our GCC, backed by our Star C. So I will stop here, and if any question, I will be happy to take. Thanks, Felipe.
Thank you very much, Ishan, Dr. Ishan, for addressing the quality control measures for solar technologies and the role of the Global Capability Center and the Star Cs in this context. Now we will start our panel discussion with our distinguished panelists, in which I will introduce. So with us here, we have Mr. Vishal Mahendru, Vice President of International Electrotechnical Commission, IEC. Mr. Jonas Moberg, CEO, Green Hydrogen Organization from Geneva. Online, we have Professor Ishan Marius Petter, Group Lead, Fortune Gristrum, Jülich. I don't know if I pronunciated these German words correctly, but I let you, Ian, to correct me. Dr. Birichi Bora, Director Technical from the National Institute of Solar Energy in India. Both the three are online. And I will hand over to our honorable moderator, Dr. Ajay Mathur. Dr. Ajay Mathur is the Professor of Praxis in the School of Public Policy in India Institute of Technology of Delhi. It's an honor, Dr. Mathur, to receive you as a moderator in this session, and I hand over to you to moderate our session to our distinguished guests. Thank you very much.
Thank you. To repeat, I am delighted to be the moderator of this session. We have a wonderful panel: Vimal, Jonas, Ian, and Birinichi. Ian and Birinichi are online, but I look forward to them participating in the discussion. All of them have been friends for many years, and I look forward to this discussion. So let me start with Vimal. Vimal, you heard Ishan talking of the global capability centers and the star centers. And my question to you is, both as a person who was one of the first movers on the electronics in the electrical industry in India, and now Vice President of the IEC, and particularly since you are looking at the small and medium sector, what is it that you see IEC and the ISA collaboration achieving? In particular, can the IEC support the various star centers that are set up by the ISA?
Thank you, Dr. Mathur. First of all, it's a privilege to be here sitting next to you. We've known each other for several decades, and so this is like coming home for me. A quick answer to your question: overwhelmingly, yes, there is a lot we can do together. Let me go back into the DNA of IEC. IEC has been around for 120 years, but we are a bunch of engineers, geekish solutions based on the problems that come to us. Over the last 120 years, we've done standards for electricity, electronics, and software. And I can assure you 99% or nearing 100% of electricity you see around us comes to you through standards written by the IEC. That we have is, as newer technologies are coming in, solar PV, especially in the last 30, 35 years, even though we have written standards, the standards are only as good as the information we receive and the people who are sitting in the room to write those standards. If we don't understand what is happening in some communities, some countries, some remote places, just because they were not in the room, or those who were in the room did not know what's happening in those outlying places, then the answer that we would have is incomplete. So one of the biggest things which I would really welcome ISA doing is telling us more about the on-ground situation, which ISA is so familiar with. IEC, based in Geneva, I must honestly confess, we do great standards, only limited to what we hear from the people who come. But for those who are not present, that's where we have a problem. And this is especially true with the global south. Many of the members of ISA are not actively involved. So if I can leave one message for all the ISA member states, please, please, please bring your paradigms, your challenges, your implementation issues on ground. And I can promise you, we will write standards that are really meaningful for you.
So I want to ask you a particular question, which has to do, the vast number of our member countries have what are called the small and medium enterprises. And what are the challenges in implementing standards in the small and medium enterprises? The fact that you are the special envoy speaks of the fact that you need a special outreach for them. Would you be able to provide us a background of the kinds of challenges that you face?
My own background is that I come from a small and medium enterprise in India, and it was started by my father when we were a small fledgling company. And so I can share even my own experience. The biggest challenge was we didn't have enough money. So how do you fund your growth, your innovation, your new products? And so we were always, if I go back 40 years into my career, we never had enough money for anything. And then trying to be innovative, I think that was a challenge. The good thing today is, and for anyone who's in the SME sector today, I can promise you capital is far more easily available today than it was ever in the past. So capital is no longer the issue. The real issue is for SME sectors, which we are trying to bridge. We don't know the real answer, or we've not hit it upon the head yet, is what are the core technologies that you invest in? Let's talk about standards, the domain we come from. IEC standards are written because in a way that there are about 173 member countries. And from those countries, whatever information we receive, we write those standards. However, some of the SMEs I have noted, especially in some developing economies, they may not have access to the latest standards. They may receive standards from some grant coming from a specific country, and those would be standards which are specific to an individual country or a manufacturer. Now, they may get a good deal on those solar panels or equipment, but is it the real thing and the right thing for the future? Does it address the local needs? Is it addressing the climate and the operating conditions of the country where the SME is trying to operate? We don't know. So one of the things I think the challenges that the SME sector faces is, are they looking at the right technologies to invest in, work with? I think, and that's where knowledge of standards domain I think Ishan showed on one of the slides, multiple organizations which are writing standards. Now you have to be careful which standards you are adopting for the technology so that they work for you. Based on that, which testing parameters are you using? That are those really addressing the operating conditions in your country or the place where you're installing that equipment? So I think those are some of the things. The third, which is closer to my heart, and I think another thing which we can do with the Star Seed program is capacity building. I mean, we keep talking about capacity building, and I don't think there is ever going to be an end to capacity building where we say we've done enough, no more. I think this is an evolving story. You know, the more capacity you have, the better is the implementation, and you can keep improving the systems, the processes, efficiency, because this whole thing is a long-term delivery. It's not a short-term project that you are installing a solar panel one time and you're out of it. You have to deliver value for the next 20 to 25 years. That's when you really get the benefit. So capacity building for almost understanding and delivering value for the whole life of the installation that you're installing.
Thank you very much. You know, it also brings in, Jonas, a personal perspective. I remember in the Bureau of Energy Efficiency, when we tried to put in standards, one of the challenge was what standards do we adopt? And believe you me, the biggest problem was in how is the testing done? And I'm going to come to you, Jonas, on it. One of the issues that happened with testing was that at that point of time, there was no testing standard for refrigerators in India. And therefore, we adopted the New Zealand standard. We also adopted the New Zealand standard for air conditioners, just made life easier. But over a period of time, two things happened. One is more labs came up. Initially, there was one lab, but more labs came up. But the second thing was we realized that the standard testing, not the standards, but the standards testing had to be Indianized. So we developed something called an India Seasonal Energy Efficiency Ratio. And the testing to be done so that the ISEER, as it was called, could be tested. And I'm wondering if we are moving towards the same kind of local climate-based interventions as far as solar panels also are concerned. But Jonas, let me turn to you. You are the CEO of the World Green Hydrogen Organization. And let me ask you, what are the kind of quality control measures that you consider are absolutely essential? First, to take off, for the world hydrogen system to take off, and then where is it that we need the tweaking so that these can make sense to the countries themselves?
Well, thank you very much. You're doing an admirable job with background noise, and I'm deeply impressed by everyone. Look, let's first establish the link between solar standards and green hydrogen, green molecules. Of course, you do not have electrolysis. You don't produce green hydrogen, green ammonia, whatever, without renewable energy. So you need solar and wind, hydropower, maybe geothermal. Huh? So now, of course, what we're hearing at every other panel here is, of course, the miracle now, the electrotech revolution, the incredible building out of solar, together with storage. And I will come back to that, because it's an important part of the story. Now, fundamental challenges we have at the moment is that while that is amazing, the building out of renewable power, of renewable electrons, we are fundamentally struggling, let's be honest, about turning those electrons into green molecules. Outside China, to some extent in India itself, one or two other places, we are not able to compete with oil and gas alternatives. We're not able to compete yet. Costs are coming down, but they need to come down further. It's one of the many things that needs to happen. And that, of course, is part of having good standards. Now, one of the magics, of course, is this combo, as I said, and I want to come back to, of solar with storage, short-term storage, even sometimes as short as 2 hours or 6, possibly even up to 8. Now, if we look at in many parts of the world, we are increasingly doing solar and storage integrated together. And that's obviously a hugely welcome development. But coming to your point, Ajay, we need to be much, much faster on the government side, on the utility side, in terms of adapting the kinds of PPAs that we are having. So how are we contracting this? So where I'm coming from to this, to a large extent, is we need to do a much greater work working together, adapting to integrated systems. And there is, of course, a third component that you've already mentioned. We got solar, integrated with short-term storage, and then O&M. We have far too many projects around the world that have never been in operation or that are white elephants. We know it. And we didn't get a lot of things right. And part of it was standards, but a lot of it was also because we did not think sufficiently about operations and maintenance. Now, there is a latest generation of PPAs. So when we sell these systems to utilities, to governments, where we have the integration of solar with storage and operation and management for 5, maybe even as far up as to 10 years. So I think we need to work a lot more closely together across governments, making sure that the PPAs, the way we set our RFPs, the way we invite developers to bid, is not just about standards, the technical standards for the PVs and so on, but that factors the latest developments here in. That is going to ensure that we get cheaper systems that we actually look after and that works.
Jonas, this leads me to the question, what are the standards that you consider to be for green hydrogen development? The key standards that you see that need to be in place for the system to go ahead. You talked of the power purchase agreements. Yes, of course. But quality assurance, what are the kinds of issues that we need to make sure? You talked of O&M, but the O&M will be according to the kinds of practices that the manufacturers ask. And the manufacturers will produce according to the standards.
Yeah, I mean, Ajay, it's almost impossible unless you tell the standards we're thinking about. Because on the technical side, we're seeing a lot of developments. And as I've started the meeting, we got to ensure that those standards are neutral in terms of the competition, particularly now between Europe and China. Those are the two markets that we are now struggling to figure out how we create a level playing field. But Ajay, I come back to my earlier point. It's much more than technical standards. One of the key areas of standards when it comes to electrolysis is actually what kind of power are we talking about? Are we talking about how do you define your renewable energy? And of course, that whether we accept so-called monthly matching or whether we require matching, that will in turn is having an absolutely essential on the kind of electrolysis systems are going for. So everything is, at the end of the day, there are a number of different variables where the standards are key. Just technical one. It is also the rules for the renewable energy. And last point, when it comes to that, it's a little bit hard to ask countries opt for the same, because countries will naturally opt for renewable energy standards that are suitable to the energy mix, energy potential, energy potential have. Yet uniformity is very important, but we also got to remember that we have to have standards that will diverge a little bit, and we need to a degree of flexibility in systems.
Can I just make I just want to make a quick comment to a point you made earlier on it's not just about technical standards. And when I talk about especially solar PV implementation, my personal experience is that technical standards, performance standards, efficiency standards, material standards, etc., are all there. What we are really missing in several projects we've seen worldwide, especially in the global south, is the complete O&M package or thinking around how you use technical standards for delivering value. I have actually visited sites in some countries which are, for the lack of a better phrase, known as solar graveyards. Reason is that you would see on top of a primary school in a village or a medical center, 3 or 4 different sets of solar panels. Funding agencies are very happy to fund, solarization or providing lighting and basic electricity in schools and medical centers. But in less than a year or 2 years, they just fail. Why do they fail? Because the parameters set by the funding agencies or by the implementing agencies was go there, install, make sure it works, and then you get paid. And they don't care about whether the installation is robust enough and it will live for a long time, whether the maintenance of those is, there is a trained team nearby, or even the people who are benefiting from it are trained enough to think of basic issues that could come in and do some preventive maintenance on their own. And so this leads to, I have myself seen 3 or 4 different solar set panels funded by global players, and they're very happy to show it in their annual reports that we funded 10,000 schools in this country. But none of those schools is happy because the panels just failed. The first time there was a hurricane, the panel just flipped. What happens then? And then the technology gets blamed. So I think we need to start looking at some of these things in a holistic manner, not just technical standards.
Thank you. Thank you very, very much. I mean, that was very useful, because what it tells us is that, as you've rightly said, skilling is part of the entire process of setting up the solar plants. So Ian, we had a discussion yesterday and we focused, I mean, at least I focused, and so did you, on the needs for standards. Now, you talk of tomorrow's standards. So obviously we are looking at performance. We're also looking, what it tells us, we're also looking at reliability. What are the kinds of standards that help in both performance and reliability from your point of view?
All right, thank you very much for the question, and also thank you again for having me on this panel. It is a great pleasure and a great honor to be here. I'll answer this by give you some examples. So I'm coming from solar cell research. I'm working with IEC standards actually every day, and let me cite to you one that I think has done a tremendous job and is doing exactly what the standard should do. This is the IEC 60904, which is telling us how we should be measuring a solar cell. And I think this is a wonderful standard because every lab and every manufacturer in the world is using it, and it allows us to compare results for solar cells across labs from anywhere, and it allows us to compete with each other. It allows us to learn from each other. So this standard, solar development has been incredibly dynamical, and I think this standard has been one to support it, right? Having this metric, the efficiency, and having an agreed upon way to measure it has been incredibly valuable for us. So this is a standard that does exactly what it should do. Similar standards apply for measuring the reliability of panels. Now, here we have a challenge because we're going to new technologies, for example, perovskite technology, and because perovskite's upcoming solar cell material is degrading and aging in a different way than silicon does, if we apply the exact same standard to this cell, we are getting results that would, for example, investors scare off from developing this material further. And in that case, the standard can do harm. Fortunately, of course, there are efforts in place to improve those standards in order to measure the material in a way that makes sense. So this is the concern that we always have with standards if you're coming from a researcher side, right? Standards cannot inhibit on the improvement, on the innovation that we are doing in solar. I give you an example of that one, for example. People that are working in solar fields are always saying it would be fantastic if we would be able to switch solar panels. So if I can take one solar panel off and put another one in. And that today is difficult because solar panels are different, right? If I buy a solar panel today, it will be different from the one that was 10 years ago. But it doesn't make sense to say we lock a solar panel onto a certain size and onto a certain power because it would completely prevent us from innovating on these aspects. So the industry needs the freedom in order to develop this. And sometimes this goes against interoperability and exchangeability. So here a standard doesn't make sense. And there is also no standard for this. And it's good that there is none. A third example I want to give where we're missing standard is we've been getting into this is the combination with battery and solar systems. So electric vehicles, to integrate electric vehicles into home systems, that has tremendous potential, but it is currently difficult because to some extent of a lack of regulation and to some extent of a lack of standards that allow to interchange between different battery system, connector system, and solar system. So here is an area where we need standards. So just to summarize this, standards can do a fantastic job if they're done well. And I think the IEC has done a fantastic job. So thank you for the ones that we are having there. And we need more of those in order to really keep the dynamic development there. And we don't need standards where it would inhibit that.
So Ian, let me, this follows up on, if you're talking of emerging technologies, and this is something, Jonas, you spoke about as well. If you're talking of emerging technologies, you're talking of, in a sense, developing new standards. This obviously means that there is interdisciplinary cooperation between, on the one side, the technical part of it, which you mentioned, but also the social part of it, the interoperability that you talked about. So how do you enable this interdisciplinary cooperation in the standard setting as it is? Maybe you would like to answer this as well.
This is a fantastic question. I'll try to keep it brief. coming from research side, I can give you examples for how this is working out well. And this is if we have interdisciplinary research projects that allow to set up kind of lighthouse projects, first exemplary kind of playgrounds, testing systems, where we try to set up these new kind of systems, for example, on the combination of solar, battery, hydrogen, and vehicles, right? We need to set up a first infrastructure, build it up to see how it works. And from that, we learn, we get the data that we need in order to write sensible standards. And then normally in a good project, there is already a part integrated where people are thinking of standards and are communicating with the communities and with the bodies that are writing these standards in order to develop them. I think this is a good way to do this.
So I just want to add to this, Ian, thank you very much for talking about interoperability. One of the things that we have realized in IEC is, while being a 120-year-old organization is a good thing, but it's also a bad thing in some ways. One is that we carry a lot of legacy systems, processes, and structures with us. One of those legacies is the technical committee structure we have. So we are vertically oriented in our structure for writing standards, which are vertical around products. But interoperability really needs you to break those silos and talk between various silos. How do we enable that? So over the last 10 years, we've been working on what is known as systems committees. Systems committees recognize at their very heart that a product is not used in its isolation anywhere. Solar PV panels by themselves don't mean anything unless they are connected through wires, through switches, circuit breakers, batteries to some consumption devices. So it's a system that works together. The IEC set up a system committee called System Committee for Direct Current in 2017, which is looking at the systems aspects around this. In my personal view, in the coming times, we will see that while there will be need for product-related DCs like solar PV panels and switches and circuit breakers, wires, cables across the board, but there will be an overarching need for interoperability, coordination, synchronization of work, performance, and data. Data is becoming more important in managing these systems. And so I think the future will see a lot more systems work and system level standards coming from IEC. Hopefully that will address some of the issues, Ian, that you mentioned.
Thank you for that. I think it will. Just let me say that it's also really, really important as we are going to larger and larger integration of renewable technologies. This interoperability, these kind of standards that you just talked about become more and more important in order to enable really carbon-free electricity systems. So thanks.
Thanks very much, Ian. Benji, can I ask you, how have you handled this in India at the National Institute of Solar Energy? Because solar is clearly an emerging area. How have testing standards kept in sync with the kinds of changes that have occurred on the solar technology side?
Yeah, thank you, Dr. Mathur, for having me in this particular forum. So regarding this, actually, first of all, we are working for the component level testing. Like so, for PV power plant, we are going for testing of PV module, inverter, batteries, and other balance of systems. Other than that, component testing, we are also working regarding the installation and commissioning part. Suppose if I install a PV power plant, and after that, what is the effect during the installation by different personnel that we need to check, like we used to do the EL imaging after the installation, so that we can check the quality of the module after installation. Then also we are working for the performance monitoring of the PV power plant in the real world conditions with respect to different climatic conditions. What is the effect on the performance in terms of safety as well as reliability part? And right now, we are also working for the development of standards for PV power plant rating. Like right now, there is no IC or any IC standards exist for the PV power plant rating, where we can say that this is the rating of the power plant, and this will give the more energy output. So that's why these type of standards right now we are trying to develop.
So, Birinchi, asking you a question which may seem unfair, but makes other developing countries. How do you see the applicability of the existing standards? In a sense, you've already answered it, but how do you see the application of the current existing standards for other ISA member countries?
In some of the ISA member countries, their environmental conditions are almost like India. In India, we have around 6 climatic zones where we have temperature ranges from -40 to 50. So also our humidity level is quite high. So in that case, in most of the ISA countries, we have seen that we are in the same climatic conditions. So that's why in some of the standards where we are developing that how local climate can affect the performance as well as reliability in terms of long-term effect. So that's why in some of the cases, like I'm just talking about PV module like IC 61215 or IC 61720, which is adopted by the Bureau of Indian Standard, which is perfectly working in Indian climatic conditions. So that's why I can say that these standards will also work properly for that ISA member countries where climatic conditions are almost similar to us.
So thank you very much, Birinchi. I think we are coming to the close of the time, so I'm not going to extend this any further, but let me ask you, the audience, if there are questions. I would be delighted if you can raise up your hands, and so it'll help me merge the questions and manage the time. Yes, go ahead.
Hello. So it's obviously very important to have strong governmental supports to expand the use of solar system, right? So I would like to know what are the main barriers that member countries face when trying to scale up solar projects?
This is a question that can take several hours. But what I try to do is to answer it in a minute. The key challenge, as far as you would have heard in this discussion, is that the situation in each country is different. The other is that you've also got solar panels being imported from different manufacturers. But a third issue that was raised here was the interconnection of the PV panels with the batteries, with the hydrogen electrolyzers. It is there that we see the greatest problems occurring. So obviously, as far as Philippe was concerned, he talked about the creation of the star centers, which address these issues, and looking at organizations like the Green Hydrogen Organizations and the IEC, together with the experience of organizations like NICE and the technology development like that of ULIC, to help us move ahead. Now, this is easier said than done. What we would need is the local capability, the local capacity to be able to move ahead. And this is as much on the systems development and standard setting side as it is on the applications, operation and maintenance side, as was so eloquently pointed out by Jonas. So it's a short answer to a very short question. Let me thank the panelists. Let me thank Vimal. Let me thank Jonas. Let me thank Ian. Let me thank Birinchi for this excellent discussion that we had. It turned out to be a lot more cooperative than we had initially thought it would be. I also want to thank each one of you for being here and you particularly for asking one of the key questions that continues to bother us as we go ahead. So many thanks, and I look forward to seeing all of you very soon. And Philippe and Ishan, many thanks for making this happen.
And hello. And a very warm thank you for all of you, panelists, Dr. Mathur, and our audience as well. We are on time to close, but I will invite Dr. Miridula to give a few words for the closing remarks. Thank you.
Ladies and gentlemen, as we draw this insightful session to a close, it's my honor and privilege to deliver the vote of thanks on behalf of International Solar Alliance. First and foremost, I extend my heartfelt gratitude to our distinguished moderator, Ajay sir, and panelists who have enriched today's dialogue with their expertise and vision. Philip, thank you for setting the context, and thank you, Ishan, for presenting the overall picture of ISA's vision for addressing quality control measures of solar technologies through the GCC, backed by existing StarC centers in our member countries. Thanks, everyone. And the session has underscored the critical role of harmonized standards, robust testing frameworks, and collaborative mechanisms in building resilient and investor-ready solar ecosystems. The GCC and StarC initiative stand as beacons of ISA's commitment to quality, sustainability, and innovation. Thank you again, all participants online and in person, policymakers, developers, investors, and our collaborators for your engagement and continued support to ISA. Together, we are laying the foundation for a future-ready clean energy economy. Thank you. We close the session now. Wish you all a great day ahead. Thanks a lot.